Hey there, Okuma fans. Charlie with the Goscar Application staff. Today we're working on fixture tracking, or CALL OO88. I'm on the road today, so this is going to be a kind of a rudimentary video. I don't get to do all the flashy stuff I usually do, but we'll get the gist of it, right? So what we're doing here, we have our static fixture tracking system for horizontals that we're working on today. The code to activate that is CALL OO88. That is 2 O's, not zeros. CALL OO88. And I had a customer give me a shout and say, hey, you know what, I'm having a little trouble with it, and I'd really like to know if it's functioning properly. How can I check it? So here's what I'm doing. I have my regular tombstone sitting here, this little guy. And then I just stuck a block of material on there. You know, doesn't matter what it is. Put a tool in the spindle, and I prefer a pointed tool, but right now I've got an end mill. That's going to work for us. So I want to set a work offset for this this block, as I usually would, you know, with a Renishaw probe, an edge finder, however I would do it. But I need to have a work offset set for that. Then I have to make sure that my tool is gauged properly. So right now, my work 0 is the face of the material, and the X0, Y0 is this upper corner right here, right there. So just to show you how this is going to work, I'm going to call up that work offset, G15H1. We'll execute that little code, and now I will say G0 to X0, Y0. And the machine will now position the tool directly over that corner. And if I G56 HA Z.1, that means read the tool height offset, move to 100 thousandths over the top of the part. Zoop. Now, if I blow up my collision avoidance screen here, you'll notice that. Let's move it around so we can see. My tool is positioned. Oh, that disappeared. That's perfect right there. My tool is positioned directly over that corner of the material and 100 thousandths from the face of the part. So there we go. You see, it'd be easier for you guys on an actual machine, but now I can see that, yeah, okay, the tool, if it were pointed, would be directly pointing at that upper corner of the material. Now that that's taken care of, I'm going to get the spindle out of the way. G0, Z50. We'll get him all the way out. Zoop. Now, because I picked, give me the big screen again, Charlie. Because I picked the upper left corner of the block, that means that I have to rotate in the B270 direction, put the material behind us. If you are wanting to do this easily, you could probably pick the upper right-hand corner so that you could swing to B90, and that way you can see instead of having to climb into your machine. But hey, I just happen to have the ability to look at the top of the part, so I don't really care that I'm swinging to B270. So now we're going to exercise the command for fixture tracking. CALL OO88 is the fixture tracking macro. And now here's where you might be ever so slightly different. If it's an older machine, the codes that you need are going to be PH, PP, PB. If your machine is newer, it will be HH, BB, and PP. But in my case, this is an older version of the macro. So if you would like to move your origin in your CALL OO88, you would start by putting in an X, a Y, and a Z that would represent where your origin is moving from that corner. But in my case, I'm not moving the origin, so I'm going to lose that. First thing I'm going to put in is the PH. That is asking me, what is the work offset that you used when you set this part? In our case, it was G15H1. Now it wants to know I'm about to write a new work offset to represent the rotation of the part. What offset can I have? And that's a PP. So I'm going to give it offset number 5. And the last thing I need to tell it, that I must tell it, is where are you moving the B-axis? So there I'm going to 270. Now, I enter that, and I'm going to hit cycle slam. Watch offset number 5 right here. Zoop, there. And now populated on where the material will be after it rotates. So let's go ahead and give it a shot. We're going to first tell it. Oh, and you notice that it also made that work offset active. It automatically does that. When you do a call OO88 and you specify a PP, that offset will become active immediately without you having to call it up. So now let's just say G0 to B270. And obviously we'll see the zoop. I don't have shortest distance turned on, but you get the point. Let's go ahead and center this up a little better so that we can see what the heck's going on. There we go. So now my origin is still that corner, but I've moved the axis 270 degrees. So now let's tell it G0, X0, Y0. And because we exercise the call OO88 when we command X0, Y0, zoop, look at where the tool went. And now G56, HAZ.1. Zoop. Now if I did everything right and my call OO88 parameters are set properly, that tool should now be pointed at that same corner and 100 thousandths away from the material. So let's look at it from the back side. Boom, got it. So I know now from that little test that my call OO88 on this machine is calibrated properly. Now when it comes to fine tuning, you're a couple of thousandths off here or there. That's going to be a whole different parameter, and I would suggest that what you want to do is look in your fixture tracking manual that should have come with the machine. Let's see if I can get that centered up a little better for you. Oh, wow, being on the road stinks. There you go. So there it is. The fixture offset tracking manual has a macro that we can use, outlines the procedure, and then tells you call OO89 with the modification to X and Z that you can key in and fix any errors. But at least now you know how you can prove to yourself one way or the other if you've done it right, if the parameters are set at least close. Hope this helps you out, and I look forward to seeing you out there in the field.